All right, we are looking at the modulus of Z today. So what is the modulus of Z? Well, modulus of Z, first of all, has this symbol that stands for modulus of Z. That is the same as mod Z. And that basically is the same as Z minus 0, because Z minus 0 is the same as Z. And that is, and this is the most important definition now, it's the length of the vector from O to Z. But this is your starting point of the vector. And this is the end point. So that is what modulus is about. But in terms of the algebra, seeing that Z normally is x plus iy in the Cartesian form, or in the exponential form, it'll be that, or in the modular form, it will be cos theta plus I sine theta with the r outside. And in the point form, it'll be x comma y. And so if you were to plot the point as a point, it'll be x comma y. So that will be a point there. So that's x comma y. But in terms of a vector, it is a vector from the origin in this case to this point. In terms of the length of that vector, it's defined as r, which also defined as the modulus. So the modulus of z is nothing more than the length of the vector, in this case from the origin to z. And by definition, in terms of the algebra, if you look at this here and using Pythagoras, that's x, that's y. That length there is just simply x squared plus y squared square root. And that is the length of the vector. It's simple as that. So to recap, your z is r cos theta plus I sine theta. If they give you this on the silver platter, the guy in front, that's your modulus. Or if they give you an exponential form, this guy is your modulus. Now, because it's length, modulus can't be negative. In terms of Cartesian form or component form, then you have by definition the algebra, then that's the real part, that's the imaginary part. In terms of point form, you got that. In terms of the vector form, well, you have to draw it before you can draw the vector. And that's where that is. Yeah. So a complex number can be represented by 1, 2, 3, 4, 5, and finally the representation of the diagram is there. So 1, 2, 3, 4, 5, 6 different ways of representing a complex number. As Z, as mod arc form. So this is mod arc form. This is exponential form. This is Cartesian form. And this is point form. And this is vector form. It is as a vector. But I want to emphasize the definition of the modulus. So when you go to take the modulus of z, that's easy. But when you take the modulus of z1 minus z2, let's say, well, you have to know the meaning of what's inside this modulus sign though. The inside says it's the vector from z2 to z1. So therefore, when you do this to this, when you take the modulus of that, that's going to be the length of the vector from Z2 to Z1. And that's very important. That's extremely important that you know that. What about you have, what is Z minus Z1? Well, by the same token, wherever that's minus, that's where you start. So this is the length of the vector from Z1 to Z. That's what that is. So that's the length of the vector from Z1 to Z. What about this one? So I'll give you an example. If you have Z minus 3 plus 4i, and you take the modulus of that, what does that mean? You have to change it into Z minus Z1 form. Like at the moment, it's not in the form of Z minus Z1. So you have to change it into the form of Z minus Z1, and that involves algebra. That involves algebra. Now that's your Z, and this is your Z1. So that means that it's the length of the vector from 3 minus 4i. Very important that that has to be minus. So from that point to this Z. So where is Z1? Well, it's 3 minus 4i, so it's here. And then that's where you start. And so let's say that Z lies on this circle here then. Let's say this represents some Z, and this is your Z1. Then the length of vector from Z1 to Z, any point on that, say that Z lies lying on this circle, that would represent. So this value of R from here to here would represent then the value of Z minus Z1, which is the length of the vector from Z1 to Z. Very important that you know that. On the other flip coin, it says 3 minus 3i minus Z, let's say. Right? How do you change this into a Z? So this then is like this. This is already Z1, and that's Z. So it's in the form of Z1 minus Z. Well, that's the reverse. This is actually the length of the vector from Z to Z1. So it's backwards this time. So if your Z is here, let's say, and this point is 2 minus I. So 2 minus I, 3i is over here. That's minus 3, and that's 2. And that was over here, 3 and minus 4. So this is now your Z1. So this time, it's the vector from Z. So let's say Z lies on there. Then it's this one this time. So it's a vector from Z to Z1. And it just happens, though, that one of the properties of complex number is that if you take the modulus of, you can see the diagram there. If you take the modulus of Z1 minus Z, it's the same with Z minus Z1. And you can easily prove that, by the way, because you can rearrange this bit into minus Z1 using algebra. And one of the properties of complex numbers is that when you take the modulus of two complex numbers, there's an invisible minus 1 here, by the way. You can take the modulus of minus 1 and the modulus of that separately. And of course, the modulus of 1 is just 1. And then you get that. And so it's the same as that. So it's important that you know the definition of what modulus means, particularly in terms of a Z minus something. So recap, Z minus Z1, that is a vector from Z1 to Z. So it's from this guy to this guy. And if you take the modulus of that, then it will be the length of the vector from Z1 to Z, and that's where we stop from there.